Hello all, in this presentation we are going to discuss about problems in community medicine. These are the set of the problems which we are going to discuss in this presentation. It is broadly divided into two categories, that is epidemiological exercise and statistical problems. Under epidemiological exercise we are going to see case control study, cohort study, screening, incidence, prevalence, attack rate, secondary attack rate, fertility indicators, mortality indicators, chlorination of well through RX apparatus, malarial indicators, filarial indicators, population estimation, calorie calculation. Statistical problems, measures of central tendency and dispersion, coefficient of variation, standard error, confidence interval, relative deviate, standard error of difference between two means and proportions, chi-square test. This is the rough outline of marks are distributed in practical examination. First, in the morning, most of the colleges or the departments follow this pattern. First, they start with the problems. That is 2 problems, 4 marks, which will give 8 marks. And the spotters, which will give 5 marks. OSPE, which will give 5 marks. Out of this practicals, clinico-social case will get 12 marks. And this 12 marks will be more of subjective assessment. It is determined by multiple factors. But the remaining segment is more of objective type, especially in problems. The answers will be objective. Once the answer and your formula is correct, you are going to get full marks. This presentation is going to concentrate on these problems. So in the afternoon, usually they will have this viva. Previously it was combined with practicals. Now it is combined with, so that also you need to focus. So hopefully you have seen all my previous presentations of definitions and mnemonics. That will be useful for your viva. So now first we are going to see about epidemiological exercises. We start with the case control study. So here we have this contingency table or 2x2 table where the outcome will be always on the top. So outcome is important, that will be on the top. Exposure will be on the left side and yes will be always, positive will be always first in both this contingency table for case control study, cohort study and also in screening test. Here how outcome is in the top. Same way gold standard or the truth will be in the top in screening. So here we have named it as A, B, C, D. So in case control study, apart from the exposure rates which we can calculate odds ratio. Odds ratio is the most important indicator for case control study. When it is equal to 1, there is no relationship between the exposure and the outcome. When the odds ratio is less than 1, the presence of exposure will prevent the outcome to happen. We are going to see one problem here. So same way we have given breast cancer present and absent, status of oral contraceptives present and absent. Question is given is calculate exposure rates, odds ratio and interpret the results. Cohort study, the same way exposure will be here, the outcome or the disease will be here, A, B, C, D will be plotted here. What we can calculate, how a cohort study is different from the case control study is, we can calculate incidence rate. What was called as exposure rate there, in case control, here it is incident rate. So that is given by the formula A by A plus B among the exposed. For the non-exposed, it is C by C plus D. Based on this, we calculate this with the same table. So we calculate an important indicator corresponding to this odds ratio. Here it is the relative risk. So incidence rate among the exposed divided by incidence rate among the non-exposed will give the exact how many times the exposed are more risk of getting the disease. Attributable risk, that is given by the formula incidence rate among the exposed minus incidence among the non-exposed divided by incidence among the exposed. Attributable risk is nothing but out of the total cases, how many cases are contributed by this particular exposure. Population attributable risk is out of the total cases, how many cases can be removed when this exposure is absent in the community. So it is given by the formula incidence of disease among the total population minus incidence among the non-exposed by exposed. So here instead of exposed we have total population, here in population attributable risk. Here one problem with the cohort study, lung cancer present and absent, cigarette smoking present and absent. So with this 2x2 table we are supposed to calculate the incidence rate, relative risk, attributable risk and population attributable risk. Incidence rate among the smokers is given by the formula A by A plus B, which is 10 by 10 per 1000. So incidence rate among the non-smokers is 1 per 1000. So relative risk is A by A plus B divided by C plus D, so which will give 10 as a relative risk. What is the interpretation here is, The smokers are at 10 times more risk of developing lung cancer than the non-smokers. Attributable risk is given by the formula incidence among the exposed minus non-exposed by incidence among the exposed, which is 90%. So of all the cases of lung cancer, 90% of the cases are contributed by the smoking. Population attributable risk, it is given by the formula incidence among the total population minus incidence among the non-exposed divided by total population, which will yield 86.3%. So that is, if we remove smoking from this community, we will reduce 86.3% of cases from the community. So that is the interpretation for population attributable risk. So so far we have completed case control study, cohort study. We are moving to the next chapter, that is screening. As I told, how outcome was in the top. Here we have the disease or the gold standard or the truth will be on the top. Positive will be first. So be positive in life. Always positives will be here. Here it is called as true positives. This is true negatives and false positives and false negatives. In screening, we have 4 important indicators, that is sensitivity, specificity, positive predictive value, and negative predictive value. Sensitivity is defined with this phrase, that is positivity in the deceased. Out of the total deceased, how many are truly positives? So otherwise, sensitivity is defined as the ability of the test to detect true positives among the deceased. So true positives among the deceased will give true positives by true positives plus false negatives into 100. So it will be expressed in percentage, so 100. So specificity, it is given by the phrase negativity in health, that is the ability of the test to detect the true negatives among the healthy is called as a specificity. So true negatives by true negatives plus false positives. The other important indicators are positive predictive value, true positive by true positive plus false positive. Negative predictive value is equal to true negative divided by true negative plus false negative. For this predictive values, for positive all will be positives here. For negative predictive value, all will be negatives here. So now we are moving to the problem. Here it is a table which is given as a gold standard, which is present, disease present and absent, and rapid diagnostic test which is newly developed. We are going to test the sensitivity and specificity, positive predictive value and negative predictive value with this gold standard. So we have got these results. Now we are calculating the sensitivity based on the formula which is given, and we are getting this results as 80%, 88%, 44.4% and 97.5%. So in case if you are getting any difficulty in following up the problem and the solution, you can pause the video and you can continue. So now the next important topic is indicators of morbidity, that is incidence and prevalence. So morbidity indicators, incidence is the most important indicator. So the key word here is the new cases. So the number of new cases of specific disease during the given period, time period, divided by population at risk during that period. Attack rates are given by the formula. The same way it is a new cases, but in a specified time interval, especially during the epidemics, we calculate these attack rates divided by the total population at risk during the same interval. How a secondary attack rate is different from a attack rate is that it is the number of exposed person developing the cases, that is the number of new cases, but within the range of a single incubation period. That is very important here for the secondary attack rate, divided by total number of exposed, that is for the susceptible contact. Here we have to exclude the vaccinated, and those who have recurrent the disease has to be excluded from the denominator. 7 cases of hepatitis A occurred among 70 children attending its child care center. Each infected came from a different family. So the number of persons in the 7 affected was 32. Within an incubation period, 5 members of the 7 infected children also developed hepatitis A. Calculate the attack rate in the child care center and secondary attack rate among family contacts of those cases. So attack rate is given by the formula number of new cases of specific disease during a specific time interval, that is 7, divided by total population at risk during that interval is 70 into 100, so which will give 10%. Secondary attack rate the same way, within one incubation period was 5. So total number of exposed person, again we have to remove the susceptible, then we will get the secondary attack rate as 20%. In the morbidity indicators, we are moving to the prevalence. Prevalence is again 2 types. One is point prevalence, the other one is period prevalence. In incidence it was new case, here it is old and new case for prevalence. So old and new case in a specified point of time. It is a period prevalence, it is a mid-interval population at risk. So that is the period prevalence. During a survey conducted during September-December 2019, 480 cases of diabetes mellitus were detected in a town with total population of 60,000, in which 180 cases were recently diagnosed. Calculate the following: incidence rate and prevalence rate, new and old cases combined, divided by the population at risk. So which will give 3 cases per 1000 population per year and 8 cases per 1000 population per year. Wherever rates are mentioned, we need to mention the denominator here and also the time period also per year fertility indicators. So before going to the fertility indicators, we should be thorough with this time points. So this is the birth of the child, live birth. This will be called as a live birth. So before this, any death which happens, that too between 28 weeks and the normal term is called as the stillbirth. That will be called as stillbirth rate. Again, when this the period between 28 weeks and the first 7 days will be called as perinatal period. If a child is born live and die within 7 days, it is called as the early neonatal period. This first 28 days is called as neonatal period, out of which the first 7 days is called as early neonatal. The next 3 weeks is called as late neonatal. And from the second month to the 1 year, it is called as post neonatal. And the whole infancy period, that is 1 year, is called as the infancy or infant mortality, if any mortality happens during that time. So we should not confuse between the post neonatal mortality rate and late neonatal mortality rate. So late neonatal mortality rate is the last 3 weeks during this neonatal period. Post neonatal mortality is after the neonatal period during the infancy, that is 1 month to 1 year. So stillbirth rate, of which all these formulas includes total live births as a denominator, but still perinatal death and stillbirth combines this late fetal death also in the denominator. So you can witness here. And in IMR, it is the number of deaths of children less than 1 year of age divided by total number of live births. Mortality ratio, it is the number of maternal deaths during a given period per 1 lakh live births during the same period. Crude birth rate is number of live births divided by estimated total population. Fertility indicators problem. In a population of 32,000 in Tamil Nadu, the following vital events were recorded in the year 2019. Number of births is equal to 480. Number of deaths in the first 4 weeks of birth is equal to 4. Number of deaths after 4 weeks equal to 5. So we need to draw this timeline properly, and maternal deaths is equal to 1. So calculate birth rate, neonatal and post neonatal mortality rate, infant mortality rate, and maternal mortality rate. So it can be calculated by this. So birth rate is, when we substitute into the formula, we will get 15 live births per 1000 population. And neonatal mortality rate, it is 8.3 neonatal deaths per 1000 live births. Post neonatal mortality 10.41. So you can substitute and check all these formulas and work out. You can pause the video and you can check out if you want to calculate. Mortality indicators, crude death rate, which is given by the formula number of deaths divided by mid-year population. Proportional mortality rate, which is given by the formula number of deaths from the specified disease divided by total number of deaths of all causes. So it is the proportional mortality rate. Out of the total mortality, how many proportions are due to that particular disease is called as proportional mortality rate. Case fatality rate is the killing power of the disease. That means out of the total cases affected, how many deaths happen due to the disease. So total number of deaths divided by total number of cases will give case fatality rate. Disease specific death rate is the number of deaths due to the particular disease in the calendar year divided by the total population. So this is crude death rate. Disease specific death rate will have the mid-year population as a denominator. Proportional mortality rate will have total deaths. Out of total deaths, how many deaths are contributed by the disease. For case fatality rate, it is total number of cases in the denominator and total number of deaths in the numerator. For a town with 2 lakh population, 4,000 deaths due to various causes were reported in the year 2019. Out of the 600 RTA cases reported, 200 deaths were declared. Calculate cause specific mortality rate due to RTA, proportional mortality rate for RTA, case fatality rate of RTA. So we can substitute in the formula and we can calculate like this. We can get 1% as cause specific mortality due to RTA, proportional mortality rate as 5%, case fatality rate as 33.3%. So in chlorination of well, we have 3 important steps. One is the calculation of the volume of the water level. Second is the amount of bleaching powder required to disinfect the well. And third is the procedure to mix. So for calculation of the volume of the water, circular well it is pi r square h, rectangular well it is LBH, conical it is 1/3 pi r square h. But here we should focus only on the water level, not on the depth of the well. Amount of the bleaching powder required is given by the formula. If suppose the third cup shows blue color, then it means 6 gram is needed to disinfect 455 liters or 1 gallon of water. So the amount of bleaching powder required is always given by the formula. After calculating the volume of the well, we have to substitute here. Then the number of cups, which is changed the color 3. Actually in the formula it is missing here. So into 2 has to be there. Divided by 455 will give the amount of bleaching powder required to disinfect the well. Then the procedure we need to explain. That is, first we need to mix it with the water. Then we have to take out the lime from that. Then we have to put that bucket in the center of the well, immerse it down and up and to the sides. And that's how we should release the chlorine to all the ends. Chlorination of well, so the depth of the well is given, 7 meter water level is given, 6 meter diameter is given, and 4th cup onwards, which means so we need to take this 4. So write the steps involved in chlorinating the well. So we need to calculate the total volume of water. So after calculating the total volume of water, so 4th cup showed blue color. So 8 grams is needed for 455 liters. It is not liquid amount of chlorine, it is liquid amount of bleaching powder. So which will give 3.4 kilograms of bleaching powder is required to disinfect 1,98,000 liters of water. So now we are moving to the malaria indicators. It is annual parasite incidence, annual falciparum incidence, slide positivity rate, total number of positive slides divided by total slides examined, slide falciparum rate, and annual blood examination rate. Out of the total population, how many slides are examined is given as a annual blood examination rate. Out of the total slides examined, how many positive slides are present? That is slide positivity rate. Out of this population under surveillance, how many cases are present? That is called as annual parasite incidence. So if we replace it with the parasite with the falciparum, it will yield annual falciparum incidence of falciparum rate. It is surveillance data for malaria of an area with population of 40,000 is given below for the year. This number of fever cases, vivax cases, falciparum, blood examined. So we need to calculate all this using the formula, and the answers will be like this. So you can pause and check the answers. Now we are moving to the next filariasis indicators, which is the 3 key important indicators are microfilaria rate, filarial endemicity rate, filarial disease rate. Microfilaria means total microfilaria in blood, total person showing microfilaria in the blood. Filarial endemicity means microfilaria or disease manifestation or both. So we have to combine all these 3 persons, and for filarial disease rate only with the persons with the disease manifestation. Total number of population examined will be the denominator in all these cases. So that is the denominator for total number of population examined for all these filariasis indicators. 1.5 lakhs population filarial survey was done. Microfilaria was there. Microfilaria is here. 310 is here. 68 and both were there. So we need to calculate the microfilarial rate, disease rate and endemicity rate using the formula, and we can calculate this. You can pass and work out the results. Population estimation. The population of Tamil Nadu was 62.4 million in the 2001 census and 72.1 million in 2011 census. Estimate the 2018 population and mid-year 2018 population. So we need to calculate the population like this. So from 2001 to 2011, how much was the increase? So that will be calculated for the 10 years. So average per year, this is the increase. So how much it is going to become for the next 7 years, that we need to calculate. So we need to add that number with the 2011 census. So we will yield a result. If it is for the mid-year population, again we need to calculate. So for the July 1st, we need to add and we need to calculate this. Now calorie requirement is the last exercise, epidemiological exercise. What is the carbohydrate requirement of 61 years old, apparently normal man weighing 62 kg? He has spent 900 kilocalories for his physical activities. So basal metabolic rate we need to calculate, that is 62 kg. Every hour there will be 1 kilocalorie loss will be there. So 1 kilocalorie per kilogram per hour. So that will yield 1488. For the basal metabolic rate will be 10% less after 60 years. So we need to reduce that 148 out of it. So we will get 1340. And for his physical activity we need to add 2240. So 2240 kilocalories will be supplemented to him. So 70% of this should be supplied with the carbohydrate, and 4 calories are obtained from 1 gram of kilocalories. So it will give 1568 kilocalories should be obtained 392 or 400 grams of carbohydrate. So that is the calorie prescription. Statistical problems. So we start with the measures of central tendency, mean, median and mode. The mean is otherwise called as average. This is otherwise called as arithmetic mean, calculated by sum of all observations divided by total number of observations. Median is the central value. After arranging all these values in either ascending or descending order, then we have to take out the central value, which is called as the median. So if the number is too big, then we need to calculate with the total number plus 1 divided by 2th value will be considered as the median. Mode is the most repeated value. Here are the measures of the dispersion. That is range, which is given by maximum minus minimum value, and standard deviation, which is given by the formula root of sigma x minus x bar the whole square divided by n minus 1. in case of the samples less than 30, that is when n is less than 30. When n is greater than 30, we can calculate as standard deviation is equal to root of sigma x minus x bar the whole square divided by n. Then coefficient of variation is given by the formula standard deviation divided by mean into 100. For calculating the standard deviation, we need to put the tables like this. Usually they will give 10 values in order to get your n minus 1 as 9. So your square root will be easy. So they will give 10 values. So we have to put the 10 values. We have to calculate the mean of that values. X minus x bar we have to calculate. X minus x bar the whole square also we need to calculate. And we have to get the sum of x minus x bar the whole square divided by n minus 1. Then that will give the standard deviation. So midterm circumferences of 10 children in centimeter are given as follows. So calculate the measures of central tendency. Mean, we have to sum all these observations divided by 10 will give 11.7. Median, that is arranging all these values in ascending order, will yield 11. Mode is the most repeated value, that is 11 is the most repeated value, that is it appears 4 times. Measures of dispersion, it is a range, that is the values will be between 10 to 14. The minimum value is 10, maximum value is 14. So maximum minus minimum value 14 minus 10 will give 4. Standard deviation, we need to put the table and we need to calculate with the formula sigma x minus x bar the whole square divided by n minus 1. Here it is, since it is less than 30 here. So one more problem. The mark obtained by 10 individuals in a subject are as follows. 28, calculate the mean deviation, standard error and confidence interval. Here, more than the standard deviation, we are supposed to calculate the mean deviation, standard deviation and the confidence interval. So mean deviation is given by the formula sigma x minus x bar by the n. Standard deviation is, we all know we can calculate. Standard error is given by the formula standard deviation by root of n. Standard error is nothing but standard deviation divided by root of n. Confidence interval is 95% confidence interval is always plus or minus 2 standard errors. So which is explained here. Standard error of mean is given by the formula standard deviation by root of n. Confidence interval 95% is equal to mean plus or minus 2 standard errors. So 2 standard errors will be calculated from the standard deviation. Standard error of proportion is given by the formula root of pq by n, where p is the prevalence, that is the proportion, how many proportion you have. Q is 100 minus p and n is the total sample. Critical ratio is given by the difference divided by standard error. If the actual difference divided by the standard error is greater than 2, then there is a significant difference. Let us suppose we obtain a random sample of 25 males aged 20 to 24 years whose mean temperature was 98.14 degree Fahrenheit with a standard deviation of 0.6. What can we say of the true mean of the universe from which the sample was drawn? So we need to apply standard error here. The standard deviation is given here. So we need to calculate the standard error, which is 0.12. So we now set up the confidence intervals on the basis of the normal curve distribution. If the limits are set out at the true standard error from the mean, 95% confidence interval, the range of the population mean would be 98.142 plus that is plus or minus 97.90 to 98.90. The chances will be only 1 in 20 that the population mean would be outside this 97.90 and 98.38. Difference between the means and the proportion. Standard error of difference between two mean, which is given by the formula standard deviation square of one group and the standard deviation square of the other group, and the sample of the one group and the sample of the other group. Standard error of difference between two proportion, it is P1 Q1 by N1 plus P2 Q2 by N2 square root. Testing the two different means, 318 and 370 as a mean and 10.2 as a 24.1 as a standard deviation of the two groups. So when we apply the same formula, standard deviation, applying the same standard deviation here and the n here, when we calculate the 7.4, this is the standard difference. The actual difference we need to calculate. What is the actual difference between this thing is 370 minus 318, which will yield 52, which is actually more than the twice that of the standard error. So then we need to, the critical value is more than 2, then there is a significant difference using the standard error of two means. Now one more formula for standard error of proportion. That is, we have this proportion here, two proportions 24.4 and 16.2 actual proportion, and the number of cases also given. PQ by Q1 by N1 plus P2 Q2 by N2, this whole square root. So 24.4 and previously 24.4 and 16.2 is the important number. So with the 90 and 86 as the number of exposed that we need to take out, we need to calculate this standard error of difference between two proportions. And then we need to calculate the observed difference, that is 8.2. In other words, the observed difference between the two groups is less than the twice the standard deviation. So we can straight away calculate the critical value, that is 8.2 divided by 6.02. Here it is even, it is less than 2. So hence we infer that there is no strong evidence of any difference between the two efficacy of the two vaccines. Therefore, the observed difference might be due to a chance. So we can conclude that way. The chi-square test is an important test of significance for two categories. So when we are comparing a two category, that is for example gender and exam result as pass and fail, then we have to use this chi-square test. We have 4 important steps here. First, we need to define the hypothesis. That is a null and alternate hypothesis. Null hypothesis means it says there is no relationship between the exposure and the outcome. But alternate hypothesis says there is a relationship between the exposure and the outcome. Second step is to calculate the chi-square value. Third step is to calculate the degree of freedom, which is given by row minus 1 into column minus 1. Usually we will calculate 2/2 table. So degree of freedom will be always 1, because it will be 2 minus 1 into 2 minus 1, that is 1 into 1, which will give 1 as a value. Probability value, we need to look at the table for this probability value. So here is one example of an exposure and an outcome is getting compared with the chi-square test. So these are all outcomes or categorical variables. So yes and no. So we need to apply this chi-square test here. So we have this A, B, C, D. These are all the observed values. So we designate it as O1, O2, O3, O4. These are all the observed values in each cells. We need to calculate the expected values also. Expected values is given by the formula. For this particular cell, the expected value is given by the row total into column total divided by grand total. So for this expected value, we need to calculate like this: 40 into 40 divided by 70. For this cell, the expected value will be 40 into 30 divided by 70. For this 10 cell, we need to calculate by 30 into 40 divided by 70. Like that, if we are debuting the values for each of these cells. So observed value is 30, 30, 10, 10, 20, and each of these expected values were calculated. And we need to calculate observed minus expected, and observed minus expected the whole square, observed minus expected the whole square divided by expected. We need to summate these values. We will get the chi-square value or the test statistic. Then the third step is to calculate the degree of freedom. For, as I told earlier, for 2/2 table, it will be always going to be, the degree of freedom is going to be 1. Then we have to look at the probability table values. If we are looking at the probability table values, degree of freedom will be 1 here. So we have to look at this row alone, not nothing else. So only this row. So we always look at this 0.05 cutoff of probability. So 3.84 is the number which you need to memorize in case if they are not giving this probability table. So 3.84 is the number which you should remember. So 3.84 is the number which you should remember. Chi-square value for degree of freedom 1, when it is greater than 3.84, then the p-value is going to be less than 0.05. So if you look at here, when the 3.84 is getting increased, the p-value is getting reduced. So the chance of p-value is nothing but the chance of committing an alpha error. So alpha error is nothing but rejecting null hypothesis when it is true. You reject the null hypothesis and accept the alternate hypothesis. So here is one example for chi-square test: heart rate increased and not increased, trial treated and not treated. So we are applying this exposure expected value in first cell, second cell, and third cell, and fourth cell. So we are calculating the cell values and the chi-square statistic, and we will get this 3.40 as the chi-square statistic. Degree of freedom is for 2/2 table is going to be 1. Chi-square value cutoff is 3.84. So since this 3.40 is less than this 3.84, so chi-square value is calculated as 3.4, which is less than the table value. So the test is not statistically significant. So you cannot reject the null hypothesis, reject your alternate hypothesis. So with this presentation, we are coming to the end of these problems in community medicine. I am wholeheartedly thanking Dr. Tamilarasan, Dr. Abhinaya, Dr. Neetu George, all my colleagues who helped in making this presentation. Please send your feedback through comments. Thank you very much.